Okay, so these are going to be the answers for skill set 1. So skill set 1, it comes up quite often in this homework booklet, but it's all about standard form and indices. So this is the revision bit where you can look at. So we've got how to work out standard form. So if we were to put a number into standard form, the power, the 4, comes from how many times our number would have been times by 10, basically. So the quick cheat way is to count how many numbers after the first. So you can see we've got 1, 2, 3, 4 numbers after the first. So that's why it's to the power of 4. It has to be, this number here has to be between 1 and 10. It can't be 0 point something. It can't be 45 point something. It has to be 4.3 or 5.6. It has to be between 1 and 10. If you have a negative, that means you're gone into decimals. So the smaller the number means you have a negative. So like I said, sometimes you have to adjust it. So if you've got 45 times 10 to the power of 6, that's actually 4.5 times 10 to the power of 7. So if we are moving, if we are timesing by another 10, then we would add another number to our power. If you were going the opposite way, so if we had 0.5 and we wanted to turn that into a proper standard form, and we would then need to subtract 1 from the power. So if you've got 0.52 but you need to change it to 5.2, we would subtract 1 from the power. But if you need to add in a decimal, then you need to add your powers. Add another 1 to your power. When you're multiplying standard form, we're going to do, you just need to multiply your numbers. So do 4.2 times 2 first, and then do 10 to the power of 5 times 10 to the power of 4. When you are multiplying these together, so rules of indices, you just add the powers. So 4.2 times 2 is 8.4, and 5 to the power of 10 times 10 to the power of 5 times 10 to the power of 4 is 10 to the power of 9. Exactly the same with dividing. Divide your numbers, divide your powers. When you're dividing numbers with powers, you would subtract the powers. A bit easier if you're adding and subtracting in standard form. Just put your numbers, take it out of standard form, so write them as ordinary numbers, add them or subtract them, and then put it back into standard form. That one is an easy one. Our rules with indices, so like I said earlier, if you've got powers and you're timesing, you can just add your powers. If you've got powers and you're dividing, so as long as this stays the same, so if you had, for example, x to the power of 3 times y to the power of 5, you can't add them. That has to be the same, that letter or number has to be the same. So timesing, you add your powers, dividing, you subtract your powers. If you've got numbers involved as well, multiply your numbers. You're not adding the big numbers, okay, you only add the powers. So you do 7 times 3, 21. Then you do your a's, so I do a to the power of 6, add a to the power, times a to the power of 5, we just add those. And then b to the power of 2 times b to the power of 3 would be b to the power of 5 because we add them. Exactly the same when it comes to a division. So don't forget this fraction line does mean divide. So I would work out my top first. So 10 times 4, 40, x power 3 times x power 5. I add that to get 8. This means divide. So 40 divided by 5 is 8. And then we can subtract our powers. Bit of harder rules now. So this would just be in higher tier. If you've got anything to the power of a minus, it becomes 1 over. So you basically just flip it. But don't forget to actually work out this bottom value. So if you've got, for example, in this one, 3 to the power of minus 2, that means 1 over 3 to the power of 2. But work out 3 to the power of 2 because they'll normally ask you to find the value of. So they'll want 1 over 9 as your answer and not 1 over 3 over 2. Example, if you've got anything towards a fraction, that means the root of it. So if you've got 1/2, that just means the square root of it. If you've got 1/3, that means the cube root of it. For example, 8 to the power of 1/3 would be the cube root of 8. So what number times by itself 3 times gives you 8? Well, the answer is 2. A little bit harder fraction ones. So if it's not a 1 at the top, your m, the number at the top, just goes to the power. So for example, if you've got 27 to the power of 2/3, you would take the cube root of 27, just like you would do up here, but then you just square your answer. So the cube root of 27 is 3, because 3 times 3 times 3 is 27, and then you just square it. Okay, so whatever number goes on top, you do that at the end. Anything to the power of 0 is 1, no matter what the number is. So if you've got 1,000,000 to the power of 0, it's still 1. Right, let's go through these answers. So first one, when we've got y to the power of 7 times y to the power of 4, that's just going to be y to the power of 11 because we just add our powers. So y to the power of 7 times y to the power of 4 is y to the power of 11. We add our powers. If we've got anything to the, I'm going to go across. So if we've got anything to the power of a half, that means the square root of 9. We should know what the square root of 9 is. That is 3. j to the power of 8 divided by j to the power of 3. When we're dividing, we just subtract our powers, so that's going to be j to the power of 5. If we've got anything to the power of a minus, that means we flip it, we put it 1 over, so that would be 1 over 2 squared. And don't forget to actually work that out, that is 1 over 2 times 2, which is 4. Next row, anything to the power of 0 is 1, so 7 to the power of 0 is just 1. If we've got t to the power of 6 times t to the power of minus 3, just because that's a minus, doesn't mean you do anything different, you still just add your powers. So I'm going to do 6 add minus 3. If I do 6 add minus 3, that's just 6 take away 3, which is t to the power of 3. Anything to the fraction is the root of it, but we've got a third here, so this is going to be the cube root of 8. Cube root of 8 is 2. Exactly the same when we've got powers. When we are dividing, we just subtract them. So this is going to be t to the power of 9 subtract minus 4. When we are subtracting minus 4, that turns into 9 add 4, which is 13. Okay, so those were our indice ones. Let's have a go at the standard form ones underneath. So 780,000. So this would be 7.8 times 10 to the power. And then we would just think about how many times you would times 7.8 by 10 to get that first number. I like to just count the numbers after my first though, so it's quicker. So I go 1, 2, 3, 4, 5. So that is to the power of 5. Right, next one, I think this is 65 million. So we've got 6.5 times 10 to the power of, again, I'm just going to count my numbers after that 6. So this would be where my decimal would be. So 1, 2, 3, 4, 5, 6, 7. So that's to the power of 7. Next one is a decimal one. So we know this is going to be to the power of a minus. So we've got our numbers 0.047. So it's going to be 4.7 times 10. So that first number, don't forget, has to be between 1 and 0. It can't be 47. It can't be 0.47. It has to be 4.7. And then this one, you would go, how many times would you move your number until you get 4.7? So your number would move 1 twice. So our decimal doesn't move, but our number would move 1 2 times. Or you can count your zeros for our smaller numbers. So it would be to the minus 2. Next one, again, our number needs to be between 1 and 10, so it's going to be 3.7. I like to count my zeros for this one. You can't count your zeros for the bigger numbers. Don't forget you count the numbers after the first. But for this one, you can go 1, 2, 3, 4, 5. So this will be 10 to the power of minus, because it's a smaller number, to the power of minus 5. Okay, next ones. These ones are working out with standard form. So when we are adding in standard form, you can take your numbers out of standard form, add them, and then put them back in. So our first one, we've got 3.4 times 10 to the power of 4. That can be written as 3. And then we need 4 numbers after the first one. We've got the 4, we have 1, 2, 3, 4. Our second number, 2.6 times 10 to the power of 3. We've got our 2. Then we need 3 numbers. So we've got the 6 first. That's 1, 2, 3. So we're just going to add those together. I'm just going to line them up underneath to add them up. If you can do that off the top of your head, that's fine. So we've got 0, 0, 6, 6, 6, 3. Just showing people how we work that out. And then we're going to put that back into standard form. So 36,600 is going to be 3.66. So all our numbers are not 0. Times 10 to the power of 1, 2, 3, 4. To the power of 4. When we are multiplying in standard form, so the second one across now, we're going to multiply our numbers. We're going to do 2 times 3.1. So 2 times 3.1 is 6.2. Then we're going to multiply our powers. So I'm going to do 10 to the power of 7 times 10 to the power of 3. When we're multiplying, we add those numbers. So it's going to be 10 to the power of 10. So you can put your answer together is 6.2 times 10 to the power of 10. With our next one, again, dividing exactly the same, we're going to divide our numbers. So I'm going to do 9.9, so divide our numbers first. 9.9 divided by 3.3, which is 3. Then I'm going to divide my powers. So I'm going to do 10 to the power of 8 divided by 10 to the power of 3, which is 10 to the power of 5, because we do 8 take away 3 to get 5. We put our numbers together, so we've got 3 times 10 to the power of 5 as our answer. Last one, we're multiplying. So we're going to multiply our two numbers. So we're going to do 3 times the 4.2, which is 12.6. Then we're going to multiply our powers. So we've got 10 to the power of 6 times 10 to the power of 5. When we're multiplying, we just add our numbers. So this is going to be 10 to the power of 11. We put them together, which is 12.6 times 10 to the power of 11. However, this is not correctly in standard form because this number is not between 1 and 10. So we have to correct this number. So we would just basically need to move our number once to the left, to the right. So it's going to be 1.26 times 10, and we need to add 1 to the power because you would then times it by another 10. So it would be to the power of 12. Okay, we're going to go through task 2 as well. So we've got y to the power of 6 times y to the power of 7. We would just when we're multiplying, we just add our power, so it's going to be y to the power of 13. Anything to the power of half is a square root. So we've got the square root of 36, which is just 6, because 6 times 6 is 36. When we're dividing, we subtract our powers, so it's going to be t to the power of 5 minus 5. When you have minus and a minus, you just add them. This is going to be t to the power of 10. When we've got anything to the power of minus, we flip it. It's 1 over 3 to the power of 3. We can't leave it like that. We have to work that out. So 3 times 3 times 3 is 27, so it's 1 over 27. Anything to the power of 0 is just 1. When we're dividing, we subtract. So we've got t to the power of minus 7 minus another 3. That would give us minus 10. If we've got anything to the power of a third, I think that's exactly the same question as above, but we would take the cube root of 8, which is 2, because 2 times 2 times 2 is 8. We've got our mixed one now, so we've got I'm going to do the top first. So if we've got x to the power of 5 times x to the power of 4, we add those, so that's x to the power of 9. It's still over x to the power of 2. That means divide. That fraction means divide, so we can subtract those to get x to the power of 7. Some standard form now, so we've got 39,000, that's going to be 3.9 times 10 to the power of 1, 2, 3, 4, because there's 4 numbers after the first. Next one, we've got 4.1 times 10 to the power of 1, 2, 3, 4, 5, 6. I like to tick them off because otherwise I'll probably miss one. Next one, this is a small number, so it's going to be to the power of a minus, so we've got 1.7 times 10 to the minus, and you can count the zeros for this one, so 1, 2, 3, 4, and 8.7 times 10 to the minus 1, 2, 3, 4 again. Right, calculating in standard form. First one is add-in. So when we're adding in standard form, we can just write our numbers out of standard form, add them, put it back in. So our first number goes 3, and then we need 5 numbers after the first because it's to the power of 5. So we've got 1, 2, 3, 4, 5. And we're adding 2.3 times 10 to the power of 3, so that's going to be 2. And then 3 numbers after the first number, so we've got 1, 2, 3. So we're just going to add them up. Obviously, we could have done this off the top of our heads, but I'm just showing you how I would add this up if they were trickier numbers. So this in standard form is going to be 3.623 times 10 to the power of 1, 2, 3, 4, 5. Next one is multiplying. So this would be just multiply our numbers. So I'm going to do 2.5 times 3 first. So 2.5 times 3 gives me 7.5. Then I'm going to do 10 to the power of 6 times 10 to the power of 2. So 10 to the power of 6. Times 10 to the power of 2. When I'm timesing, I'm just going to add those powers, so that's going to be 10 to the power of 8. I can bring those together as 7.5 times 10 to the power of 8. Last two, so when I'm dividing, I'm going to just divide my numbers. I've got 8.4 divided by 4.2, that's just 2. Then I've got my powers, so I've got 10 to the power of 9 divided by 10 to the power of 4. When I'm dividing, I'm just going to subtract my numbers. So I'm going to do 9, take away 4, which is 5. I can put those together, which is 2 times 10 to the power of 5. Last one is timesing, so I'm going to do 7 times 3. So 7 times 3 is 21. Then I'm going to multiply my powers. So I've got 10 to the power of 3 times 10 to the power of 4. When I'm timesing, I add my powers. So that's 10 to the power of 7. I can put that together, 21 times 10 to the power of 7. However, that's not in standard form. That needs to be 2.1 times 10, and I can add 1 to that power, which is to the power of